Alright, today we're going to be working with finding exact values using radian measure. In the last lesson you learned how to convert from radian measure like pi over 3, 2 pi, and 7 pi over 4 to degree measure. Today we're going to use that skill in order to find exact values of trig functions. These are the three examples we'll do, so let's get started with the first one. So find exact value of sine pi over 3. In order to do this, the first thing we need to do is to convert pi over 3 to degree mode. So to convert pi over 3 to degree mode, we multiply it by 180 over pi. So here I'm going to multiply by 180 over pi. My pi's will cancel, and 180 divided by 3 equals 60. So finding the sine of pi over 3 is the same as finding the sine of 60 degrees. You'll recall when we found exact values before, we used the function values for special triangle. In your textbook you'll find it on page 54. So the sine of pi over 3 is the square root of 3 over 2. It's the same value that of finding the sine of 60 degrees. So our answer to this problem is the sine of pi over 3 equals square root 3 over 2. And that is our final answer. Let's move on to example 2. So in this problem, we're asked to find the exact values of cosine 2 pi, and the first thing we need to do is convert 2 pi to radian measure. Now I'm hoping, in all honesty, that you remember what the conversion is for 2 pi to degrees, because the main conversion factor that you have to remember is that pi equals 180 degrees. So if pi equals 180, then 2 pi equals 360. But let's go through the steps. To convert from 2 pi, you can multiply by 180 over pi if you didn't realize what the conversion factor is, and we end up with 2 times 180, which does equal 360 degrees. So in order to find the cosine of 2 pi, we're going to use, it's the same as the cosine of 360 degrees. If you look at that table of values, you'll notice that we just have values for 30, 45, and 60. So for this problem, we actually can't use the table of values. We have to go back to recall something that you learned earlier. So whenever you're stuck on a problem like this, it's always a good idea to go ahead and graph it. So this is a 365 degree angle, and the ordered pair that corresponds to this angle, since it ends there, would be over 1 on the x-axis and 0 for y. So the ordered pair would be 1, 0. In this case, my radius, would equal 1, and the definition for cosine is something else you have to remember in order to solve this problem. Remember the cosine of theta, when we're using those coordinate plane definitions, the cosine of theta is x over r. So I need to use my x value and my r value to figure out this problem. So the cosine of 2 pi, which is the same as cosine of 360 degrees, and after we graphed it, we found out that our x is 1 and our r is 1. So the cosine of 2 pi equals 1. Okay? Let's move on to the third example. And in this example, you're asked to find the exact value of tan of 7 pi over 4. So just like in the previous problems, our first step was to go ahead and to convert 7 pi over 4 to degree measure, and we convert 7 pi over 4 to degrees by multiplying by 180 over pi. And in this case, my pi's will cancel. And then I'd have to multiply 7 times 180. I'm going to show this as 2 separate steps, but you don't really need to do this as 2 separate steps. Because I don't like multiplying big numbers as much as possible, I'm going to simplify, because I know that 4 goes into 180 45 times, and 7 times 45 7 times 45 is just 315. So let's go ahead and note that. It's just 315 degrees. So if we go ahead and graph 315 degrees, we end up right here. And you'll recall from the previous lesson that what we needed to do then is to find this reference angle right here, the measure of this angle that is formed by the x-axis and the terminal side of the given angle. And in this case, the reference angle is 360 minus 315 is 45 degrees. Okay, so now I know to find the tan of 7 pi over 4, I need to use the tan of 45 degrees. So let's come over and look at our chart. 45 degrees is one of the special angles, so the tan of 45 degrees is 1. So I know that the answer to this problem involves 1, but there's one more thing that you have to remember when figuring out the tan of 7 pi over 4. It may be 1 or negative 1. And to figure out which one it is, we consider the fact that this angle ends right here in the 4th quadrant. And angles that end in the 4th quadrant, only cosine and secant are positive. So that means that the tan of any angle that ends in this quadrant is going to be negative. So the tan of 7 pi over 4 is negative 1. And that ends our lesson on finding exact values using radian measure.